When you think of iron, you probably think energy, right? Feeling less tired, having healthy blood. But what if I told you it's also a master commander in our body's constant war against disease? Let's dive into the absolutely fascinating secret life of iron.
So could the key to fighting disease be hiding right there in our own blood? Well, that's exactly what we're going to dig into. We're going to uncover how this one simple element, iron, is playing a secret double life right at the heart of our immune system.
Okay, so let's start with the basics, the stuff we all kind of know. Iron is a powerhouse. It's fueling our energy through ATP. It's a building block for our DNA. And of course, it creates the red blood cells that shuttle oxygen to every single part of our body. Super important. But, and this is a huge but, iron is a true double-edged sword. On one hand, it's absolutely essential for life. On the other, if it's left uncontrolled, it can generate these things called reactive oxygen species. You can think of them as tiny molecular grenades that go off inside our cells, causing all sorts of damage. So our body has to perform this incredible balancing act 24/7.
So how does our body walk this tightrope? How does it manage this powerful yet dangerous element? It all starts with our immune system's first responders, our innate immunity. And believe me, iron is pulling all the strings here.
All right, quick refresher, just so we're all on the same page. Your innate immune system is your body's frontline defense. It's the first on the scene, it's super fast, it's not picky about what it attacks, and it's made up of tough cells like macrophages and neutrophils that just rush to the site of an invasion.
Okay, and this is where it gets really cool. Iron basically dictates how one of our most important immune cells, the macrophage, behaves. It can flip it between two completely different modes, attack and repair. In attack mode, it's pro-inflammatory. It actually hoards iron to help it fight off bacteria and even tumors. But in repair mode, it's anti-inflammatory. It releases iron to help heal tissue and build new cells. Think about that. Two totally opposite jobs, and iron is the switch.
And it's a surprisingly direct link. If you have high iron levels, it tends to push those macrophages into that aggressive attack state. If iron is scarce, they shift over to the calmer repair state. Getting this balance right is absolutely critical. You need to be able to fight an infection, but you also need to be able to heal the damage afterward. It's a perfect example of iron's crazy dual role.
You know, our bodies are just brilliant at this. There's even a strategy called nutritional immunity. It's basically an iron lockdown protocol. As soon as an infection is detected, the body hits the brakes on absorbing iron from your food. Then it scrambles to lock up any free-floating iron inside special storage proteins. And the end game? You starve the enemy. The invading bacteria are literally deprived of the iron they desperately need to survive and multiply. It's such a clever tactic.
Okay, so that's the front line, the first responders. But what about the elite forces of our immune system? Well, iron's influence gets even more complicated and, frankly, kind of weird when we look at our adaptive immunity.
So if the innate system is the local police force, the adaptive immune system is like the special forces. They're highly specialized, they create a very specific, long-lasting defense, and they remember the enemy using elite T cells and B cells.
And if you thought that last part was complex, hold on, because this is where it gets a little wild. Just take a look at this. For some T cells, like the helper T cells that coordinate the whole immune response, iron actually hits the brakes on their development. But for the killer T cells, the ones that actually destroy infected cells, it hits the gas. And then, just to mess with us, if you use iron as part of a vaccine, it can suddenly supercharge the very same cells it was holding back before. It's not a simple on-off switch. It's more like a super complex mixing board.
Okay, thankfully with B cells, things get a little more straightforward. For our B cells, which are basically our antibody factories, the message is crystal clear. We need iron, period. Without enough of it, they just can't multiply effectively, and their ability to churn out the antibodies we need to fight infections takes a major hit.
So, that's a lot of theory. What does this all mean on the actual battlefield of disease? Let's take a look at how this all plays out with stuff that really matters, like cancer, infections, and even the aging process itself.
This quote from the research really says it all. In conditions where people have way too much iron in their bodies, like hemochromatosis, they actually become more vulnerable to infections. Why? Because you're basically leaving out a feast for any invading pathogens, giving them all the fuel they need to grow and overwhelm your defenses.
And with cancer, man, this is where you really see that double-edged sword in action. It's incredible. On one hand, we can now use FDA-approved iron supplements to deliberately force macrophages into that anti-tumor attack mode. But on the flip side, some sneaky tumors have figured out how to hijack the system. They use certain macrophages as their own personal iron donors, getting them to deliver iron that helps the cancer grow faster. It's both the hero and the villain in the very same fight.
And this story doesn't stop there. It even plays a huge role in aging. See, as we get older, iron tends to slowly build up in our tissues. This accumulation is linked to something called cell senescence. That's basically when our cells get old and just stop dividing. It also makes it harder for our bodies to heal properly. It's yet another example of how too much of a good thing can cause real problems over a lifetime.
So all of this leads to a really exciting question. Now that we're starting to understand this double life, what if the future of medicine isn't just about creating new drugs, but about learning how to precisely control this one element, how to harness the power of iron?
And get this isn't some far-off sci-fi idea. It is happening right now. Look at these two therapies. They are complete opposites. On one side, we're boosting iron with drugs like ferumoxytol to activate those tumor-fighting macrophages. On the other, we're blocking it with things called iron chelators, which basically starve several types of cancer. We're actively learning how to wield both sides of that double-edged sword.
So where does that leave us? We've seen iron act as a commander, a weapon, a fuel source for disease, and even a factor in how we age. This is a huge shift in thinking. It's not just a nutrient anymore, it's a powerful regulator of our entire immune system. Which leaves us with a pretty powerful thought. Could mastering this one, single element be the key to the next great frontier in medicine?